February 15, 2013, a Wednesday morning in the Ural Mountains. People were just starting their day. Then, a flash brighter than the sun, a shockwave that blew out windows across 6 cities, and 1,500 people went to the hospital. The rock that did it was only 18 meters across, small enough to fit in your backyard, and it never even hit the ground. That's the puzzle of Chelyabinsk. It didn't leave a crater, it didn't hit the ground at all. So where did all that energy come from, and why did it matter? The answer is in the air, literally. Here's how the timeline unfolded. At 9:20 in the morning local time, a roughly 18-meter asteroid entered Earth's atmosphere at 19 kilometers per second. It traveled from east to west, approaching from the direction of the sun, invisible until it was too late. Seconds later, at an altitude of about 30 kilometers, the immense pressure and heat caused it to explode in an airburst equivalent to 500 kilotons of TNT. 2 minutes after that, the shockwave reached the ground. Windows shattered, walls buckled. Over 1,500 people were injured, mostly from flying glass. No one was killed, but the event made headlines worldwide. To put that energy in perspective, compare it to the Hiroshima bomb. The Hiroshima bomb released about 15 kilotons of TNT. Chelyabinsk was over 30 times more powerful, 500 kilotons. That's roughly the yield of a modern strategic nuclear weapon. A rock the size of a bus released the energy of a sizable warhead, but without the radiation, and detonated high in the atmosphere. That's the difference between an airburst and a ground-level explosion. So why didn't Chelyabinsk leave a crater? Because it was small enough that the atmosphere did the splitting. When a meteoroid traveling at hypersonic speed encounters the dense lower atmosphere, the pressure against its front face is enormous. It compresses the air ahead of it, heating it to tens of thousands of degrees. That heat, combined with the pressure, literally tears the rock apart in a catastrophic explosion, an airburst. The energy is released in a flash and a shockwave, but the object itself never hits the ground. For objects under about 30 meters across, airbursts are the norm. Only larger objects, like the one that made Meteor crater in Arizona or the one that ended the dinosaurs, are big enough to survive to the surface. Let that sink in. The object was only 18 meters across, smaller than a standard city bus, but because it was moving at 19 kilometers per second, its kinetic energy was enormous. The airburst blew out windows across 6 cities. Over 1,500 people sought medical treatment, most from cuts caused by flying glass. No crater, no ground impact, but real human consequences. This is why planetary defense isn't just about dinosaur killers. It's about the everyday threat from objects we barely notice. Step back from the shattered windows of Chelyabinsk. Look at the broader sky. The same solar system that sent that 18-meter rock contains thousands of similar objects, but we are watching. Surveys like Pan-STARRS and Catalina are scanning the sky every night, and missions like DART have shown we can actually move an asteroid if we need to. Chelyabinsk was a surprise, but it won't happen again unnoticed. Check your understanding. Why did Chelyabinsk cause injuries even though it didn't leave a crater? Pause the video and commit to an answer. The correct answer is B. The airburst produced a shockwave that shattered windows, leading to over 1,500 injuries. There was no crater, no radiation, no direct hit. The shockwave was the culprit. First, you now know the key facts. Chelyabinsk was an 18-meter asteroid that airburst high in the atmosphere, releasing 500 kilotons of energy, comparable to a modern strategic nuclear warhead. Second, the damage was almost entirely from the shockwave, broken windows and flying glass. No ground impact, no crater, the atmosphere absorbed the rock, but not the energy. Third, Chelyabinsk was a wake-up call that a bus-sized rock can injure thousands. That's why we now have surveys scanning for objects just like it, and why the next threat won't catch us by surprise. Up next in this section, Tunguska, a 12-megaton airburst from 1908 that leveled a forest without ever touching the ground.